All right. Realize you're now being recorded as you argue over who's faster.
I'm faster. Dude, I beat him.
Okay. I want to throw you a slight change in this one. How does it change this problem if I put a plus 5 on it? Okay, as far as the domain goes, can I still put any number inside that absolute value?
Yeah.
Yep, I can. So it stays all real.
All real, baby.
Okay, now my range, does it change if I have a plus 5?
-4.
Okay, I got a greater than or equal to 5, is that what you're saying? Okay. Yeah, because this part we already said is going to come out greater than or equal to 0, but then it says add 5 more on. So it's going to be greater than or equal to positive 5, because it went 5 more up from that.
You wouldn't have to be 5 plus 5, so that'd be 10, right?
No.
This part is 0 or bigger, add 5 more on. 0 plus 5 makes you bigger than 5. Okay? So, with that same thought in mind, what if I give you absolute value of x minus 33? Yeah, because this part's always going to be 0, a bit up, but then I'm subtracting 33 from it. So, yes, my y is going to be greater than or equal to negative 33. Now, Andrew just made a statement the domain's always going to be all reals. With an absolute value, can you make that assumption?
Liar.
No, you say if I'm wrong.
Are you saying any absolute value can always have any number put inside it?
No.
Name me a number you can't put in an absolute value.
Yeah, you did. You took my eraser.
You already tried.
Yes.
Negative.
You can always, you put anything in an absolute value. It's always all real.
That's right, boys. Take
Okay, but now I'm taking the absolute value off and I'm just making it plain old 4x.
Honestly, you got another domain.
So once again, I'm asking you domain, what numbers can I put in there for x?
That will give you 0.
They don't have to give me 0. They just have to, give me something that's not undefined or impossible, something like that.
0. So
4 times 0 is 0. You can do that.
Simple.
Yes, you can. You can put anything in an x. It's all real. All right, now range. Yes, it does. If I put positive numbers in there, y will come out positive numbers, won't it?
Yeah.
But if I put a negative number in there, I'll get negatives. So I'm going to get both positives and negatives, which means I'm going to get all real numbers then. So if it doesn't have the absolute value on it, then it can come out any number you want.
Yum, yum.
Just tell me, what if I give you 3x minus 1/4? That was supposed to be. Is it the same thing or does it change?
There's music going on in the back.
There, I'm sure Mr. Hermick is playing a video.
Oh. I'm gonna say, what the heck is that? It's obviously all real numbers.
Yes, I can put any number I want in for x. Okay, can I still get any answer?
Yeah.
I can get positive answers, I can get negative answers. So if it's just plain x the first, anything's going to work.
And those are easy.
Yes, I hope so.
No, they're not.
Okay, what about if I give you x to the second?
That's a tough one.
No, it's still gonna be the same thing.
Can I put any number in
No,
there and
0.
square it?
No, you can't.
What's 0 squared?
Zero.
So I put 0 in there. I can put anything in there. Are we seeing a pattern with the domain here?
Yes.
So what number do you take times 0 that gives you undefined? What is that? Does that divide by 0?
0 times infinity is considered indeterminate.
So if you divide by 0, is that undefined?
Then dividing by 0 is undefined, yes. Okay. So now, tell me, this is x squared on the range. What's going to happen when you square something?
It's gonna get bigger.
It's going to get bigger. What happens when you square negative 3?
It's
It becomes positive 9, doesn't it? So squaring makes all things become positive.
Does it really?
Yeah.
What?
Oh, okay, so
Okay, so I heard a y is greater than or equal to 0. You put 0 in there and square it, you'll get 0. Okay. So, hint, having an x squared is just like having an absolute value. They both make it become positive. So that, therefore, it's going to work the same way. It's going to work the same way as absolute values did. So what's going to happen if I do x squared plus 9?
All real numbers.
I can put anything in there.
Y is greater than or equal to 0.
Nope.
It's all real numbers.
This part's going to be greater, the first part's going to be greater than or equal to 0, but then you're adding 9 more. So then if I add 9 more onto that, it means everything has to come out greater than or equal to 9. So if it's anything that makes it become positive, then you're going to have to use that second number to determine your value.
Is there ever going to be a time when you can't put anything in there?
Yes. Thank you for asking. Okay, so Reggie just asked me, is there ever a time that when we can't put something in for x? I mean, that was all reals every single time. Okay, there's only one time that it's going to happen to you this year, and that's right now. If I give you something like 5 over x plus 2, Andrew was just talking to me about it moments ago. What's the one thing you could never do in a fraction?
Divide by 0.
You can never divide by 0. So you have to ask yourself, what number makes that bottom equal 0? Negative 2 plus 2 would make it equal 0. This is just like your testing points thing. You can't have negative 2 because that makes you divide by 0. But, so in this case,
You can't have 0 in this.
I can have every other number except negative 2. So how do I write that? I certainly don't want to list out all the numbers I can have. Yes. If you just want to throw out a couple numbers and say it can't be these numbers, this is domain, we just write x cannot equal negative 2. We just write what numbers it can't. Everybody in the mathematical world understands that means it can be every number except negative 2. That's an understood concept.
That's what I'm talking about.
Now, I'm not going to ask you to do range on the fractions because that gets really tricky depending on what the number on top is bigger or the number on the bottom is bigger. And
That's going to be on the assessment stuff, you know?
no.
No.
No. Juniors have to take state assessments if they did not get a passing score last year.
Oh, yeah, that's probably me, dang it.
Even I made that.
Yeah, nobody passed. That's probably Nicole. And,
Oh, baloney.
she's in,
So, in this case, you have to think a little harder. I can't have whatever makes the bottom equal 0. So how did we figure out on testing points what makes that equal 0?
Obviously,
Set it equal to 0.
We set it equal to 0 and we
Man,
solved
I
it.
could.
That's good, yeah. So then we subtracted 7. And so negative 7 halves is the number that equals 0. Or 3 1/2. I'll take decimals if they're exact.
So
Don't
you
round
can't
them.
have them. So you can't have 7 halves.
So you would say x cannot equal negative 7 halves. And leave it at that.
Who did it?
That's what your entire worksheet is. This stuff. You just have to- Just about.
recording the entire time.
No, I just turned it back on. I'm not that insane. Alright, so no, we're turning it back on. That's the end of domain and range. This last part, you should know in your sleep.
Yeah, Frank, yeah.
That was on tape.
It's not a bad word. Yeah, even a word. Yeah, it is. Yeah, go type it out. It's the type of weed.
Okay, moving on to lines. Lines are our primary topic of this chapter. We're going linear like no other here. Okay, well, I will tell you, lines are my biggest frustration as a teacher. Lines, I teach them and teach them and teach them, and we beat you with them year after year after year, and I can't get them to stick. Why?
Beat you with them.
I rack my brain for why does this not stick with us?
No one likes lines. Nobody's straight.
But the tons of things in this world are linear. Very useful. So, if I once again draw you a really rough sketch of a line here. Okay, What could you tell me about that line?
It's a diagonal.
What are the important things we want to know about a line? It is a diagonal line. Is it steep?
No. It's not steep.
Yeah, no.
How do we measure how steep a line is?
Oh, you got it as a video.
Whoa, thank you.
Oh my God.
No, I don't want to do slow.
Okay, what were you taught is the definition of slope in words?
Rise over run.
Thank you, it is rise over run.
Oh, if yours says this, I can do this.
It's just this today.
Thank you. But we don't
So,
have to do that
what
for
is the slope of that line I drew over there?
Negative 2 over 3. No, it's 2. Positive, you go up. Negative, you go down.
So if you start from this point,
Go up 2.
if you start from the left-hand point, you would be rising 2
Go over 3.
and running 3.
2 over 3.
But what if you had started on the other side? What if you'd started over here?
Negative 3, negative 2.
Then you would have, your rise would have been
Oh, negative 2.
down 2, and you would have been left 3. So they both would have been negative, which is still positive 2/3. Okay, I assume that that is not a revelation to you.
Do what?
Slope is not a revelation to you, I hope. Okay. What we fail to see, though, we teach you lines, is we fail to make the connection with what a line tells us about things in the real world.
We actually use lines.
Yeah, we actually use lines a lot in the real world. Slope is nothing more than telling you the rate of change of something.
Rate of change.
The rate of change. If I told you, for example, that the price of a McDonald's hamburger went up,
$1. So now it's $2.
I'm going to say $1.50 every 2 years.
The rib hamburger is small.
Okay, so it rose $1.50. The run would be years going across 2 years. So in other words, how much did it change per year?
50 cents.
Try your math.
75.
Wait, I didn't even hear the question. I just thought $1.
$1.50 divided by 2 would be 75 cents per year. It represents a rate of change. If I was to graph that on a graph, I would simply have, my graph would be rising 75 cents for every year it moved over. Whenever you talk about how fast something is changing, you're talking slope. Everything we do. So slope is really a very valuable thing. Out in the real world, in the business world, you'll see them. If you ever have the pleasure of taking an economics class,
Oh, I will.
they'll draw a graph of, okay, this is what our production level is. Okay, that's what we call supply. That's how much you're producing. And yeah, ooh, you know supply and demand.
Yeah, we learned that in history class last year.
Woo, yes. Okay, demand. Actually, I drew that the wrong way. Sorry, I should have done that the other way. Because supply, you would start with a lot in supply, and then your supply would drop as people buy your products, unless you're reproducing. Demand is going to hopefully increase. What you want to know is where do they match up? Where do they intersect? Where is supply and demand going to match each other? Because that tells you exactly how many you should produce. You don't want to produce too many and spend money you don't need to, but you don't want to produce too few so that people can't get what they want. So we spend a lot of time trying to figure out where the supply and demand lines overlap each other, which is what we do with the chapter after this one. We find where lines intersect.
Sounds like fun.
Lots of real-world uses for these. Okay. I, however, needed to just, right today, check, because you know the basics of how to find that. Thanks. I was hoping to get done here. I'm not far. I suppose pause it now, because I'm really, really close, but...